Tokenization in natural language processing. AI intermediate level. Introduction. Human language is written in the form of sentences and paragraphs. But machine learning models cannot directly understand raw text. Before computers can analyze language, the text must first be broken into smaller units. This process is called tokenization. Tokenization is one of the first and most important steps in natural language processing. NLP. It converts raw text into smaller pieces called tokens, which can then be processed by machine learning models. Tokenization is widely used in applications such as chatbots, language translation systems, sentiment analysis, search engines, text classification. Understanding tokenization is essential for building AI systems that process human language. What is tokenization? Tokenization is the process of splitting text into smaller units called tokens. Tokens can represent words, characters, subwords, sentences. In simple terms, tokenization equals breaking text into smaller meaningful pieces. Example concept. Sentence means tokens. Example: I love artificial intelligence. Down pointing arrow. I love artificial intelligence. These tokens become the basic units used by NLP models. Why tokenization is important? Machine learning models cannot directly process raw text. Instead, they require structured input. Tokenization helps convert unstructured text into manageable components. Example concept. Raw text means tokens means machine learning model. Without tokenization, NLP systems would not be able to analyze text, count word frequencies, build language models. Tokenization is therefore a foundational step in NLP pipelines. Types of tokenization. There are several types of tokenization depending on how text is divided. Word tokenization. Word tokenization splits text into individual words. Example: I is transforming the world. Down pointing arrow. I is transforming the world. Example concept. Sentence means word tokens. Word tokenization is commonly used in many NLP tasks. Sentence tokenization. Sentence tokenization divides text into sentences. Example: I is powerful. It is changing the world. Down pointing arrow. I is powerful. It is changing the world. Example concept. Paragraph means sentences. This is useful for tasks such as text summarization, document analysis, translation systems. Character tokenization. Character tokenization splits text into individual characters. Example: I. Down pointing arrow. A. I. Example concept. Word means characters. Character level models are useful for handling unknown words. Subword tokenization. Subword tokenization splits words into smaller meaningful parts. Example: unbelievable. Down pointing arrow. Believe. Able. Example concept. Word means subword units. Subword tokenization is widely used in modern NLP models. Examples include byte pair encoding, BPE, word piece, sentence piece. These methods help handle rare or unknown words. Tokenization workflow. The tokenization process typically looks like this. Raw text. Down pointing arrow. Text pre-processing. Down pointing arrow. Tokenization. Down pointing arrow. Token list. Down pointing arrow. Feature extraction. Tokens are then converted into numerical representations for machine learning models. Tokenization example. Consider the following sentence. Natural language processing is fascinating. Quote: after tokenization, natural language processing is fascinating. The tokens can then be analyzed individually. Tokenization in modern NLP models. Modern deep learning models such as transformers rely heavily on tokenization. Example concept. Text means tokenizer means token IDs means neural network. Each token is converted into a numerical ID. Example. I is amazing. Down pointing arrow. 101. 2054. 2003. 6429. These IDs are used as input to neural network models. Example Python code. Tokenization can be implemented using libraries such as NLTK. Example code. Import NLTK. From NLTK, tokenize import word _ tokenize. Text equals I love artificial intelligence. Tokens equals word _ tokenize. Text. Print. Tokens. Output. I love artificial intelligence. This demonstrates basic word tokenization. Real-world applications of tokenization. Tokenization is used in many NLP applications. Chatbots. Breaking user input into tokens before generating responses. Search engines. Processing search queries to match relevant documents. Sentiment analysis. Analyzing individual words to determine sentiment. Machine translation. Breaking sentences into tokens before translation. Text summarization. Identifying keywords and phrases. Advantages of tokenization. Tokenization provides several advantages. Advantages include structured text representation, improved NLP model performance, easier text analysis, support for machine learning pipelines. Example concept. Tokenized text means better language analysis. Challenges of tokenization. Despite its usefulness, tokenization has challenges. Challenges include handling punctuation, processing emojis and special characters, dealing with languages without spaces, Chinese, Japanese, splitting compound words correctly. Example concept. Complex language means difficult tokenization. Researchers continue developing improved tokenization methods. Concepts learned from tokenization. Understanding tokenization helps learners understand. Checkmark how raw text is divided into manageable units. Checkmark how NLP systems prepare language data. Checkmark how tokens become inputs for machine learning models. Checkmark how modern language models process text. Checkmark how text analysis begins in NLP pipelines. Tokenization is one of the most fundamental steps in natural language processing. Simple definition. Tokenization. The process of splitting text into smaller units called tokens for analysis in NLP systems. Final summary. Tokenization is a fundamental technique in natural language processing that divides raw text into smaller components called tokens. These tokens can represent words, sentences, characters, or subwords. Tokenization enables machine learning models to process language effectively by converting unstructured text into structured units. Modern NLP systems rely heavily on tokenization to build language models, perform sentiment analysis, translate languages, and power conversational AI systems. Understanding tokenization is essential for building AI systems that analyze and understand human language.